Welcome to our video overview here of graphing rational functions. In particular, rational functions that have a horizontal asymptote that we're trying to graph by hand. First, we look at the function itself here, and it's r of x equals x plus 3 over x minus 1. Notice it's already factored in both the numerator and the denominator. That's something that's very handy for us right off the bat. So some things that we can identify from this factored form would be x-intercepts of the graph. The x-intercepts are where it's going to cross the x-axis, meaning that the y value is going to be 0. Essentially, it's the places that make the numerator of our function equal to 0. In this case, that would be x equals -3. We also like to write out our y-intercepts, and for the y-intercepts, that's when you plug in and get x equals 0 to figure out when the graph is going to cross the y-axis. If x equals 0, this will be 3 over -1, which is pretty simple and straightforward. It's just going to be -3. Now, when we look at the domain of this particular rational function, there's a problem spot in the denominator. X cannot be equal to +1. So we could say the domain is x is not equal to 1. We could also say it's -infinity to 1 union 1 to infinity, depending on whether we want the interval notation or not. Now that x value of 1, when we plug in x equals 1, we get 4 over 0. So 4 over 0, when we divide by 0, we get a vertical asymptote. So we're going to list off the fact that we have a vertical asymptote at x equals 1. And then we're going to care about what we call the vertical asymptote behavior. And in that scenario, what we're going to do is look at the limit as x approaches 1 from the left, from values slightly less than 1, of our function r of x. And we're also going to look at the limit as x approaches 1 from the right, values slightly larger than 1, of our function r of x as well. Now in each of these scenarios, if we're plugging a number in really close to 1, the numerator is going to be 4. All we really care about is identifying that it's a positive non-zero number. A positive non-zero number. Now in the denominator, if we plug in 1, we get 0. But if we're plugging in a number slightly less than 1, say like 0.9, 0.9 minus 1 would be like a -0.1. This is getting really close to 0, but it's slightly less than 0. So when we divide by 0, a number really close to 0, a limit that gets really close to 0 in the denominator, this turns out to be infinity. Since it's a positive on top and a negative on bottom, it's going to be a -infinity that limit turns out to equal. On the other hand, our other function, from the right hand side, we get a non-zero positive number, 4 specifically, divided by a number slightly bigger than 1, -1. Slightly bigger than 1, -1 will be like a positive number, really close to 0. When we divide two positive numbers, the denominator of which being close to 0, we're taking the limit. That turns out to be a positive infinity. Now we have a few other things to analyze. Specifically, we've got the vertical asymptotes going on. What happens horizontally, the end behavior, as we look at this graph? Well, here for our end behavior, we've got a function that has a power of x on the top and a power of x on the bottom, just x to the first in each case. So as x gets really, really large, this function is going to be approximately x over x, which is equal to 1. In other words, we're going to have a horizontal asymptote of y equals 1, because the limit as x approaches -infinity of our r of x function is going to be 1. If I put in a value of x really close to -infinity, the whole fraction turns out to be really close to 1. And similarly, if we plug in the limit as x approaches positive infinity of r of x, we also get that to be 1 as well. So the key aspect that we want to think about is the horizontal asymptote is y is equal to 1. The last question we'll ponder before we graph: does the graph cross its horizontal asymptote? Well, if it does, then the function itself, x plus 3 all over x minus 1, is going to have to equal 1. We can multiply both sides by x minus 1, we get x plus 3 is equal to x minus 1. Subtract x from both sides. Is 3 ever equal to negative 1? Not to my knowledge. So there will not be a crossing of the horizontal asymptote by this graph. Now we have everything we need to actually sketch the graph. So let's go ahead and do that. So these graphs do not need to be drawn perfectly on grid paper or anything. We'll just sketch out some axes. They don't need to be perfectly to scale. We'll put the x label for the x-axis, we'll put the y label for the y-axis, and now let's see what's happening. We've got an x-intercept at negative 3, 0. So over here, I'll put an x-intercept at negative 3, 0. We have a y-intercept at 0, negative 3. Here will be our y-intercept of 0, negative 3. Our vertical asymptote was at x equals 1. So we will put in a vertical asymptote, and please make it dotted so that it's clear that that's going to be an asymptote, not part of the graph. And we will label it as x equaling 1. What else do we need to get on this picture? Well, we have our horizontal asymptote at y equals 1, so let's get that item on here as well. Again, ideally that should be a dotted line. It's not actually part of our graph, so make it clear that it's not part of our graph and label it as y equals positive 1. And now before we connect the dots and draw this thing, let's label where the vertical asymptote goes. So as we are on the left-hand side of our vertical asymptote, it's going down to negative infinity. We'll put that on the graph. And as we're on the right-hand side of our asymptote, it goes to positive infinity. We'll put that on the graph. And we don't have any crossings of our asymptotes. So now it's just a matter of connect the dots. Over here on the left, we'll draw it up, and make sure you get close to, but don't cross, the horizontal asymptote. Over here on the right-hand side, again, get close to, but don't cross your horizontal asymptote. And what we have drawn in blue would be the function y is equal to r of x. It has all of the key features that we've discussed in this problem. An x-intercept at negative 3, 0. A y-intercept at 0, negative 3. A vertical asymptote at x equals 1, where it goes to negative infinity on the left and positive infinity on the right. And a horizontal asymptote at y equals 1. Please make sure all of those key features of your rational function are labeled clearly on your graph. But that's really all there is to it, especially if you're drawing the graph of a rational function with a horizontal asymptote.